In this video, we're going to look at a circuit board that can power a microbit and up to 3 servos. It also provides the connections the microbit needs to control the servos. The board is called Servo for Microbit and it's made by MonkMakes. I'll start by setting up a single servo, and as I do that, I'll walk through how to connect the board to the microbit and then also how to connect it to the servos and the power supply. So here's what we need to get started. A microbit, the servo board itself, 3 alligator clips, a power supply, and in this case our power supply is a battery pack that holds 4 AA batteries, and then finally a servo. And this servo is an SG92R, it's made by Tower Pro, and it rotates 180 degrees. So let's take a look at the servo board. It has 5 connector points on the top, and these match the 5 connector points on the microbit along the bottom. So I'm going to connect the ground, the 3 volt, and the P2. So I'm going to take the black alligator clip and clip it to the ground on the microbit, and then the ground on the board itself. And then the red will be the power supply, so I'll connect that to the 3 volt here, and then the 3 volt on the microbit. And then finally we'll take the white alligator clip and connect it to the 2 port, and then connect this down here to the P2. There we go, that's all set up. The next thing we're going to do is connect the power supply. If you look at the bottom of this board, this is where the power supply connects, and you can see it handles between a 4.5 and a 6 volt power supply. And that's what we need to operate the servos. The one issue we have here is that the microbit itself can only handle 3 volts. So this board has a built-in voltage regulator that only sends 3 volts to the microbit, but then sends up to 6 volts to the servos to run those. To connect the board, we have 2 slots down here at the bottom of it. One has a positive sign and the other has a negative sign. On the power supply we have 2 male connectors coming off of it that we're going to use. The red goes into the positive power source. I'm going to screw that down with a flathead screwdriver. And then I'm going to put the black one in the hole for the negative connector. Now the next thing we want to do is connect our servo. Now you can see the servo has 3 wires coming off of it. The brown is for the negative connection, the orange in the middle is for the positive connection, and the yellow on the end is the communication wire. On the bottom of the servo board we have 3 sets of 3 pins. Your communication, positive, and negative, and they're labeled 0, 1, and 2 to match the communication ports here. I'm going to plug this into the 2. I want the yellow wire to connect to the C, so I'm going to plug it in with the yellow wire coming out the left and the brown wire coming out the right. So that's all set up. Now the next thing for us to do is write the code. Now I'm in a MakeCode workspace and I'm going to write code to turn the servo back and forth. I want to use the logo touch sensor located at the top of the microbit to control the servo. So if the servo is stopped, touching the sensor will start it, and if it's already turning, touching the sensor will stop it. In the form of an algorithm, that looks like what you see on your screen now. To know whether to turn the servo off or on, we'll need to keep track of its current setting. Whenever the logo sensor is touched, we want to set it to the opposite of its current behavior, and the easiest way to do this is to create a variable. We'll set the variable to 1 to signal that it's currently running, and 0 to show that it's stopped. So the algorithm for this step is, when logo sensor touched, if variable equals 1, set variable to 0, otherwise set variable to 1. Okay, now let's code that up. I'll start by going into variables and click make a variable, and then I'll type in the name, and I want to name mine servo running. Okay, now I'll click on the set servo running block and I'll drag that into the on start. We'll leave it set to 0 because we want the servo stopped when we initially start running the program. Now I'm going to go into the input category, scroll down to version 2, and click on logo pressed, and that'll place it on the screen. Next I'll go into logic and pull out an if then else statement, and we'll place that inside the on logo pressed. And then I'll go back into logic and pull out a comparison block to use to determine the current setting of servo running. Now we want to evaluate servo running, so I'll go into variables and pull out servo running and drag that over the left-hand 0. And then we'll change this to 1. And then if servo running is set to 1, we want to set it to 0, so I will duplicate this block, and then I'll drag that under the if statement. And we'll leave that set to 0. We know that the only other value that servo can be is 0, so we don't need to do another evaluation, and we can just go into the else block, assume that it's 0, and set the value of servo running to 1. So I'll click on this and duplicate it, drag it under the else, and change this value to 1. Now the next step is to actually run the code if servo running is set to 1. So I'm going to drag this over here. We'll pull the forever block down. That's the one we need to work on now. So the way we're going to code it is do forever. If servo running is true, turn the servo to 180 degrees and then turn it to 0 degrees. That's the end of the if statement, and that's also the end of the forever block. So let's go ahead and write this code. We know we need an if-then statement, so I'm going to go into logic and pull out the if statement. Instead of evaluating servo running by comparing it to a number, we're just going to use it as a true or a false. So I'll go into variables, drag servo running out, and place it over the true. So if it's equal to 1, that's going to evaluate to true. Now we want to go into advanced and scroll down to pins, click on that, and then scroll down until we see servo, and we want the servo write pin block. We'll place that under the if-then block and change the value of P0 to P2 because that's the pin I plugged the servo into on the servo board. So we have servo write pin 180. Now we'll duplicate that and place that under the other servo write pin, and then we'll change this to 0. Now let's go ahead and test that. So I'm going to click on the logo and nothing happens. Okay, this is a case where we can go ahead and look at our code and make sure that it's correct. But one of the things we need to pay attention to is that we are operating a physical device. We're running a servo. So a servo takes a bit of time to turn, and this code may be running faster than this can keep up with. So what I want to do here is go into basic and pull a pause out and place that in between the two servo write pins. We'll leave that set at 100 milliseconds and see if this changes its behavior at all. So I'm going to go back to the simulator, click on the logo again, and we see it turns like it's supposed to and then starts freaking out. So we know that this is a processing speed issue. So we need to accommodate the servo by just slowing the code down enough to let the servo process. So I'm going to duplicate this. We'll drag that under the second servo write and see how that affects the behavior of the servo. So I'm going to go back over here, click on the logo, and we can see that it just kind of freaks out on one side and doesn't do anything else. So we clearly need to slow it down some more. So we'll change the speed to 500 milliseconds and see what happens then. And it's running, so I'll press the logo. No, okay, that's making it most of the way around, but not quite all the way. You could mess around with this a little and try different values, but I'm just going to go ahead and go to 1 second here. And we'll try it one more time. And you can see that it's turning all the way. Okay, so that works. Now we want to test it on the microbit and the servo board, so I'm going to download the code to the microbit. The code's downloaded to the microbit, and we can go ahead and test it. I'll press the logo, and the servo turns. And I'll press it again, and the servo stops. So that's it for this video. If you liked it, give it a thumbs up and consider subscribing to my channel. Thanks for watching.